Right, well, thank you all very much for joining me this afternoon for this latest in the Beyond Modelling webinar series that we're running. My name is Tony Waller. I think a lot of you will know me already. I've been with Lanner many years, and I'm happy this afternoon to take you through many aspects of witness displays. Some of the intermediate and advanced functionality that maybe we don't teach fully on the training course. So I'm hoping to show you a series of different models and explain how those models are put together for some of these advanced display characteristics. So I'll move across into Witness, and the first model I'm going to open, I have to find the right directory, I should have prepared that better I think, is one called tags. We're going to talk first about tag displays. What are tag displays? Well, tag displays are bits of information held in attributes which we're going to display alongside the part as a part moves through the model. So I'll just run this model, and we can see that when this person is carrying this part along this path, that the big number 4 there is displayed, and then on the next person coming through, the number 5 is displayed. This is a piece of information, an attribute pertaining to the part, where that is set up to display alongside the icon as it moves along the path display, or indeed when it's at the machine display. So wherever the part is displayed, we will see there, for example, at the machine, the number 8 is being displayed against the part description. Now, how is that enabled in a model? Well, we have identity in this model as an attribute. And if I just open up the dialog, you can see it's an integer attribute. Now, to enable tag displays for that attribute, I go to the display bar, and on the display bar, I pick draw in the first box, tag style in the second box, and then in there I can set up the way in which I want tags to be displayed. When you first come into the box, it will be shown this way with no enable tag display. But as soon as you enable tag display, you have the option to have an easy display just below it, or you can specify, if you untick that box, exactly what the X and the Y offset should be for the display from the part icon. And you can pick whatever font you want. Here I've given it the opaque text with the pink background, and I've made it really large to stand out. That may be what you want to do in a model, or you may want it to fade a little bit into the background, and I'll talk about ways of doing that a little bit later. That attribute, identity, in this model is being set on the actions at the start of the machine. So all I'm doing here to set different values is I'm sampling from an I-uniform distribution between the value of 1 and 9. And hence we're getting numbers 4, 5, 8 and whatever being sampled from that distribution. The other thing that we need to do to get the tag attribute to display, firstly we need to set that tag style, but secondly on the part style, and we can get to that by updating the graphic from the standard display that's brought in, we have to tick this box. This box says use display tags, and if we don't tick that box, for that part type, the attributes will not be shown. So you have to tick that against every part style dialog that you want that part to display the attributes on. So just seeing that move along again. Now notice, by the way, in this model, the actual icon for the part is just the red dot. It doesn't include the man. The actual output rule here for the machine is actually push to machine to with man using path. And that's the syntax, of course, for the man to go and pick up the part and to take it along the path to the machine. The man icon is completely separate in this instance. That's the labor icon. And the reason that the part appears in front of the man as it's moving along the path, that's all set up from the path dialog itself. So if we go into the update graphic from the path display, then we'll see here that we have this section down at the bottom which says multiple graphics, either in the direction of the path or to the side. So if there are two things like the man and the path which are both moving along the path at the same space, they will be offset to a certain degree, and that's controlled by this figure here, and whether you choose it to be in line with the path or to the side. So that's why we're seeing the man and the path there, and the path being shown separately. But it's the attribute here is attached to the part. Unfortunately, at the minute, you can't display attributes with tag displays moving along with labour, or you can't show tag displays next to a machine or whatever. So those specialised kind of attributes, which if you remember we define in group 0, you can't actually use. You can see them displayed against parts, but you cannot see the values against the particular labour item or the carrier or the vehicle or the machine. If I just open up my next model now, tags 2, you'll see that this kind of display is not limited to just numbers coming along. So here we've got lots and lots of different strings being attached. And of course, with strings, I've seen lots of people use tag attributes for order numbers, but certainly for unique identification. But it can be any manner of complex string, directly identifying exactly what part it is, what batch number, but may be combined in a string with a customer order number or that type of thing. So here we see it's exactly the same logic, but this time we have a string attribute. And again, we've been into the display bar. That's the only way to get to this tag display. Pick draw, pick tag style, and you're in to set up where you want that to appear. Now it's common, I would say, to not have the tags to be as large as they are in this demonstration model. So let me just show you what I would typically do for a model like this. If you were displaying a lot of information that was likely to run across other parts and you wanted to be able to read things easily, I would put a 4 or maybe even a 3 into the size attribute here, the size of the font, sorry. And I'd also pick a colour that was very close to the background colour. So I'm going to go into the light grey colour here, which is the background colour, and just define it a little bit darker than that. Add that to custom colours and make it that colour. So now you can see that virtually those tags have disappeared on this screen. But if we wanted to zoom in and see those tags, or see them more easily, I'll use this method of zooming in. Let's pick a 500% pan on the Windows control, and we can just zoom in, say there to the top, and we can see the tags very clearly, light green and maroon, the two tags, and they all move along perfectly well, but they don't get in the way of the rest of the display. If we just zoom in there, we can see one marked grey. Let's just go back out to full zoom again. And just move around with the middle mouse button there again. Set the model running. And as you can see, it's not very intrusive at all. It's important that I mention that you can actually display more than one attribute against each part at any one time. That's very easy to do. Just define a different offset so that it's displayed at a different point on the view as the parts are moving around. Now, it's also possible to extend tag displays into models where carriers and vehicles are used. And I'm just going to open up a model where I've done that. And we'll set this one running, set it a little bit faster. And we'll see now the identity of the part being carried by the vehicle is also being shown on this track and vehicle system down at the bottom. These are tracks, and it's a vehicle travelling on that system. Now you can only get displays of part attributes on vehicles and carriers if you are using a part display for the vehicle style option. So if I go to the tree here, you'll see that we have an AGV. This is doing the work on this track. If I go to the display bar again, and I pick the style for that vehicle, and we use that third button to go in. Firstly, we must have selected in this list one of the options which pertains to a part display. Now, for a vehicle, there is only one, and that is part. For a carrier, there are several. You can show a part when it's loaded and a carrier when it's unloaded, a different icon, or you can just show a part when it's unloaded and an index value when it's unloaded. But for a vehicle, you've only got the one choice, which is the part display. And also on carriers and vehicles, you have to tick the Use Display Tags button shown here for it to be enabled to show that attribute on the vehicle. Now, the default display for the vehicle when it's unloaded, when you have a part choice on the vehicle, is the lettering for the vehicle. What I've done here is I've made the lettering opaque and I've made it orange on orange, and that's why when the vehicle's unloaded on the return loop here, it's looking like a little orange blob, and I prefer that than having a text description for the vehicle. At some point, we may well extend it to have part attributes shown irrespective of whether it's the part display or not. I should also mention it is only the first part which displays its attributes as well. If the vehicle can take two parts, it still only displays a single value of the tag attribute below. So it is a little bit limited in that, but sometimes the model can be exactly in the way where you can show these tag attributes through onto the vehicles and carriers on those systems. So that was the first topic I wanted to cover with you. The next one is moving on to expressions and the use of variables for display purposes. And I have a version of my energy optimization model here. This is one from the demo set, but I've got a few extra things being shown here on the screen. One of the things that's in the standard model for this energy optimization model is this figure here, the one which is reporting against the power usage, how much electricity has been used in the model. Just to remind people, on model options, we have the costing and sustainability tab on which you can add any measures of sustainability you wish. But this graphic here is just a pure graphic that's been drawn against the backdrop. And you can draw expressions against any element in the model or the backdrop. They don't have to pertain to the element that you particularly draw them against. Here, this expression, get total usage electricity, that function is being updated every 5 time units. It's a real figure that we're updating because that can be a real amount. We have no control, unfortunately, over the formatting of that. It displays to the number of significant figures that make sense to it. Normally, about 7 different numbers before and after the decimal point in total. You can pick the font you want that to be displayed as, and as I say, you have the update interval. Now, the update interval of 5 there means that figure is only going to be updated every 5 time units that this model runs. So if I stop it at an interval that isn't at 5 time units, and here we've stopped it at 2023.25, you can see that we have a figure expressed for the total power usage there, but it's probably not fully up to date in the model. If we go to the Cost, Revenue and Sustainability report and we pick electricity, you can see that the actual true figure is reported here as 1064389.5. It's moved on a bit since it was last updated on the display. Another example of an expression here might be this one. For example, here we could just put the time up on the window. So we could update that every 10 time units. So let's watch that expression at the top in red updating as we run through. And as you can see, it is only updating every time units. This units column isn't moving at all. And when you stop the model, it's lagging behind a little bit. It's at 3310, whereas the real time is 3310.25, as we can see from the run toolbar down at the bottom. So there is they have limited applicability, the expressions, but really quite useful generally for putting up KPIs onto or key performance indicators on as a display. If you wanted a perfectly accurate figure, say, of time, and always to be updated whenever you stop the model, there's only one way to do that in Witness. This is a variable name called V1, and that variable I've displayed as a normal variable, and there I do have control over how many decimal places I want it to be. And we can put that variable to be updated in a sector in a pie chart. Now this pie chart has been defined purely for this purpose. We're never going to look at a pie chart, but we can give that a refresh interval. So every 55 time units, that pie chart will refresh. But in addition, whenever you stop a model display, a pie chart always refreshes as well. So it's going to run that expression calc time in that first sector for the pie chart at whatever time you stop the model. Let's look at calc time. It's just a normal Witness function. All it's doing is setting V1 equal to time. So V1 equals to time. And if we watch the second one here updating, it updates every 55 minutes. But when we stop the model, it aligns perfectly with the time on the run toolbar down the bottom. So that is a way of getting a very accurate expression shown or a value shown on the screen at any time. The other one, using expressions, it has only got an update interval, and you have to decide what's right for you. Now, with expressions, you can also include string information and number information. If we go in to see how this one is set up, we can see that what we've done in this is we've put a string, part shipped. We've made the whole thing a string variable or string expression, which is going to be shown. And then if we want to show a number with that, we have to convert the number to a string. So we concatenate with the plus symbol the string which says part shipped with the num to string function, which is converting the end shipped, the number shipped of the green part, into a string variable so that it can be concatenated with that other string. Of course, you could write the string up on the backdrop anyway and just have the number update as a variable, as an integer variable. But I just thought I'd show you that it's perfectly possible to bring the two together into a single display item if that's what you want to do. Of course, variables and things can be used throughout models, and I recommend variables for displaying many things in many cases, but we wanted to show you expressions as an alternative for showing some of that key information as the model runs. Right, the next topic I want to go on to is illustrated in this model, which is called flow lines. And I'll just run this model for a while. And we can see that as this model is running, we get different lines drawn and deleted between different tanks. Now, how are we doing that? Well, we're doing that with the draw line function. And I'll show you where that's done. In this model, on tank 2 warning levels, I have these actions. And the one which I want you to look at here, particularly at the minute, is not the rate adjustments, but the two at the bottom. We are drawing a line and we are deleting a line. So we're deleting line V line 1, which has previously been drawn. And we're drawing another line and we're giving it a number identity V line 3. Whenever you draw a line, you have this option to record the value in a variable so that you can manipulate it later in a model. Otherwise, it becomes part of the permanent display in the backdrop. And the parameters for drawing line are the coordinates, which are the last 4, but the second one there is the color. And that's RGB color. That's another function in Witness, which is setting it in terms of red, green, and blue function parameters. And much easier. You could just put a single number in there, but to use the RGB color function means that you have much more certainty over which color you're getting if you're used to working in those RGB parameters. So it is those functions which are drawing those lines. Now I'm recording and I'm showing here what the IDs for the 3 lines are. That's my line 1, that's my line 2, and line 3 is the one drawn to tank 4 as and when that there is a flow there. These are not pipe elements, these are just drawn lines. I do have to stress that some people seem to think they're pipe elements. But we can take one of those lines and we know what the ID is, so we could try to change the colour of that line as well. That's another thing that we can do with any display item in a model. You can actually change the colour through actions code. And if I just look, if I search in my assistant tree for the phrase colour and use the search command here and go into the functions for Witness, it tells me there are 2 which contain the word colour. One is set display item colour and the other is RGB colour, which we just looked at. And what I'm going to do is I'm going to take I'm going to use set display item colour to change some of the colours in this model. What I'm going to do first, though, is to go into user actions, and so you can see in fairly large type what I'm going to be putting in here. I'm going to use the insert with prompt to do this. Now, what display ID? Well, the display ID I want to move. I'm going to have to come out because I'm going to have to look to position my window so I can see that. Set display item color. Let's do the import again. Let's do the right click and insert with prompt. Then the display ID is 167772221, and in here the RGB integer we want to put in. Well, I can insert that property there, and we can put in 255 for red, 0 for green, 0 for blue. So that function will return a red color. And when we run that action then, that set display item color to that item, to that color, what we'll see is when I run user actions, we'll see that top line changes to a red line in the model. Now I'm going to take that function that I've written as well, that particular function there, and I'm going to put it into immediate actions down at the bottom here. Because as well as changing the display things that you've drawn, you can also display anything else you want to in the model and change the color or delete that display item interactively as the model is running. So let's pick display item 4 here. Now we don't know what display item 4 is, but we know it's going to be set to be red. So I'm going to run that display item, that function, and you can see the name of tank 2 has changed to red. If I pick item 6 in the model, then it changes the name tank 3 to red. Now the only way of finding out what a display item number is, because everything in the Witness model has its own display item, is to write a model that runs through things in step by step, changes every single item to a different color, and then check to see what number it is when you're stepping through that model. That's the only real way to determine what the different colors, what the different display IDs are. You'll notice when I re-zero this model, well, the lines disappear. I'll illustrate how that's happened in a final model that I'm going to show you, which is a model which will draw a graph for me directly on the surface here just on the modeling surface, but just using the draw line command. So here I want to have a monitor of the buffer over time. This particular model has machine 1, machine 2 with the buffer Q1 in the middle of it. And using the draw line function, I've been able to construct this graph as the model's running from hundreds and hundreds of different little line segments that I've drawn. Where's that actually done in the code? Well, let's go to the simulation tree. Let's have a look at V-lines. This is my repository for all the IDs of those lines. The reason I'm going to keep all those IDs is because I want to get rid of those when I restart the model. So where is that used in the model? Just stop the model for a minute and we can look where that's used. Well, it's set in the update graph function. And the update graph function is just simply drawing a new line on that graph. And we're calculating where that should be based on the different pixel locations. And then it's scheduling using the new schedule action from witness 13 and yet another graph update in time +5. It's running the update graph function again. The first running of the update graph function is set in initialize actions, where we're scheduling the graph update at time 5 and we're running the function update graph. That schedule function, by the way, witness 13, extremely useful for many things, not just drawing lines. Now, to get rid of all the lines on begin, we make use of another trick in Witness that's well known to the consultants, which is the only way to do actions on begin at the moment is to have a write file defined as a file element, and we know that file will be closed on begin to begin the write again for the new run. So what I'm doing there, I'm running through all those 10,000 display lines that I might have drawn, and I'm deleting those display items. So any of the lines which I've done, when I hit the begin, they'll just be zeroed out of the model, and it will start drawing that graph again. I don't think I need 10,000 lines for this particular graph, and if I let the model run on, you'll see actually the graph extends well beyond the parameters and the axes that I've allowed it to do so. So you have to control these things. I could, of course, re-zero the graph at a certain point, draw it again at any point, and change how my model is displayed. And that's just one way in which you could use drawline. There are many other applications and ways that you can use lines, colors, expressions, and then, tag display is the first thing we covered in this particular webinar. Well, that's absolutely... in an awful lot of models, you will want to use that. It's not really, it's just part of very much of the standard functionality that's extremely useful in Witness. So I don't appear to have any questions that have come through on the question bar here. Apologies if you have submitted them and I'm not getting them through correctly. But that has been the modeling Witness Displays Beyond Modeling webinar. Thank you very much. We've kept it within the 30 minutes. Thank you.